there are many kind of, I guess, domains where feature stores can expand upon. One of them is feature engineering, but I was thinking a little bit about the upcoming days of foundational models. And
Yeah.
for example, and one specific thing that is in my mind is vector databases, right?
Yeah.
Do you think there's a space for vector database capabilities in features platform offerings?
Yeah, absolutely, I do, and I can tell you about kind of like how they fit in today, and kind of how they fit into like the future as well. So it's really interesting. So what's cool about a vector database? I think the nice thing about it is it allows you to find similar things. It allows you to kind of do an operation that wasn't super easy before. I have a document or I have a user. Here's my user. Give me other similar users, right? And if you look at kind of like some of the kind of like how modern teams do recommendations. So actually first, like why is that useful? It's because then you can get a list of things that you can like rank and that you can generate recommendations for, right? And if you look at how modern recommendation systems work, they kind of have a few stages. They have like a candidate generation phase, which is like, give me a list of things that I should consider ranking. And then they have a ranking phase where they actually do the ranking, and and there's a filtering phase mixed in there. And sometimes they kind of like iterate on that a couple of times. So, for example, at Google, coming back to the Google thing, we had to rank like literally millions of ads, right? And how do you do that in real time? Well, you can't use this super expensive model. We had this gigantic logistic regression model, it's really expensive. You can't just score every single ad every single time. We had this thing where we would do a really lightweight based retrieval, like the super cheap operation to go from a million ads to say 10,000 ads. I mean, have a slightly more expensive operation to go from 10,000 to 100. And then we would say, okay, let's use the good model to score all 100, and then we'll rank by that, and then we'll only choose the top three and show the top three, right? Something like that, right? That's not exactly how it worked, but that's how like modern recommendation systems work. And in that world, where do vector databases fit in? Vector databases fit into the give me the list of all the things that I should be considering. I've got this, maybe I've got this user. I want to get a list of other users. I've got this like item, whatever, or you can do a cross entity too. You can say, I've got this item. Who are the users that are most related to this item, kind of thing, depending on how you set up your vector space. And how does that fit in with feature stores, feature platforms? Well, feature platforms are kind of helping the next stage of the recommendation, right? Where I say, okay, I've got these items. These are the 100 items that I want to consider ranking. Now I want to make a really high quality prediction for each of these 100 items so that I can then sort by those predictions. So what we would do then, after you go to your vector database and get that list of 100 say item IDs, pass that into the feature platform, and the feature platform will say, okay, here's 100 feature vectors. For each of those items, here's 1,000 features that are up to date, real time, really high quality. Your team has chosen them before. Maybe they can be based on user information, session data, item data, whatever it is. And then you can score every one of those 100 items, get a relevance score, and then rank by that and just choose the top three. So the vector database and the feature platforms side by side work really well for a lot of use cases. And so it kind of does make sense. So they're very compatible is my point. And then I think there's a kind of a question of like, what does that mean for like Tecton generally? And what we see with Tecton is we are really trying to help people build these real-time ML applications. Like production, production machine learning, we just want to be the kind of like platform where you get all of the tools you need to assemble like the production data flows that your ML system runs in real time. And so certainly a vector database could fit in there in the future. We don't do that today because I was just mentioning like we're trying to get really good at one thing before we expand. But in the future, like we want to be this kind of like real-time engine that supports all of the real-time ML operations you might need, and so we could definitely like candidate generation fits into that. And I think you can get if you combine feature candidate generation with feature retrieval you may be able to get some really nice performance optimizations that you could not get if you were operating these things completely separately. So that's something that we're thinking about for the future. But we try not to like, one of our cultural values is, and I think this is like a thing that like every ML company has to deal with, is fast but focused. And so we keep our team try to stay very clear on focus. Let's get one thing done really, really well, and let's earn the right from our customers. Let's wait till our customers are like pulling the next thing from us because they're so happy with the existing thing. And so, you know, feature platforms are still new in the industry too. So there's a little bit of a way to go there before we kind of like expand to all these other things.
And I guess it's kind of becoming a little bit more easy to do that as well, to bring in at least vector nearest neighbor search capability to a feature platform, because now all of these players like Cassandra and Redis are kind of implementing nearest neighbor search natively, right?
100%. And it's also a just like, it's an interesting question about this. So this is a thing I don't have a really strong opinion on. I would love to hear what you guys think, but what is the future of a vector database too? So we know that there's a lot of systems that are vector databases that are kind of like companies that were like, we're a vector database company. We also know, so there's kind of two kind of like risks for vector databases. One is, okay, like Cassandra and Redis and, you know, like other companies just add for their, like Postgres, just add a vector approximate nearest neighbor retrieval interface to their database, and then suddenly they're a vector database. And do the vector database companies have, you know, enough of a moat such that people will go to them, or is someone just fine just using Postgres for this, right? And this is a thing where like the right answer depends on the details of your use case, your requirements, your kind of like, what's the scale I need, a whole bunch of like technical nuance. Then you get to technical nuance. The other thing is a lot of the reasons, a lot of the use cases for vector databases today are to retrieve embeddings for items that you want to pass into prompts for LLMs, right? And that use case, I don't know the future of it, because the reason you have to do that is because your context window in an LLM is only so long. You know, it used to be whatever, a couple thousand tokens, and now it's going up and up. But you know, I just saw Anthropic released a model where it has 100,000 token limit, which is huge. That's like 70, whatever, some number of thousands of pages or something like that. And you know, what's it going to be next year? It's going to be maybe 100 times that. So is that use case going to be around? Are we going
But it is a little bit, I mean, a longer prompt costs, right? So it's a huge cost to pass, I guess, 10,000 tokens to a prompt.
No, it is, but I totally agree. But that's a problem we have today. But then I think about like, then we try to solve that problem, and maybe there's a way to cache, you know, like cache and reuse a LLM halfway through processing a prompt or something like that, that can allow us to reuse the state of an LLM once it's already had some level of a context window having been processed. And so anyway, all of that is just to say that we're very early in this space. There's a lot of uncertainty, and so there's a lot of big questions for the futures of vector databases.
I think we will be. I think that vector database or databases, vector functionality, okay, jobs to be done around vector databases will stay with us. I expect that, yes, the prompt can be like, you will be able to send bigger prompts, but I think that we will, that embedding and vectorizing stuff is more about, the essence is in extracting essence and having it in a concise ways. So I believe that we will be also using prompts with vectors to make them shorter and also save some processing time on the large language model inference. But it is what I feel. when it comes to companies around vector databases, I think that the core functionality is so low level that most likely it will be basic offering of a cloud provider like vector database.
I agree. It will be so. So yes, it will be an offering from a cloud provider. It will be an offering from like Reddit. Redis already has it, right? You know, like folks like that. And then I think the question is, but does a specialized vector DB have enough kind of like unique value to kind of economically justify its existence as a separate company and
I
a
don't
whole
believe.
industry?
I don't
You
believe
don't think
that.
so? Yeah. So I don't know.
I guess speed
I
is
was
not
just
that important, right? Because vector-based databases probably provide speed, I guess, over a regular,
I
let's
think
see, Redis.
I think okay, so I think it would be tough to beat Redis on speed, but it would be there's probably a lot of we can imagine a bunch of dimensions. Developer workflow, cost, flexibility, types of, there's a whole bunch of things like how many vectors can you retrieve at the same time, performance cost trade-off, stuff like that. All of those things, like this is just like a whole area where there's a whole bunch of solutioning that can be done. Um, but I agree. Like I don't think vectors dealing with embeddings is going away at all. I think it's super powerful. We have people putting vectors into like embeddings into the feature platform, where they're retrieving those as features. And some of the things that we want to be doing is helping people build those, helping people because they're just features, right? And helping people keep those up to date and manage all the versioning of that. That's one of the things that was super valuable at actually at Uber. It was really successful for a lot of the stuff, particularly in Uber Eats. I just remember that team adopting embeddings and going crazy with them, and they got a lot of stuff done, a lot of impact from that. So we're really bullish on embeddings. We think there's a lot to do there. And so that's actually a pretty big focus for us in the near-term future.